good time of day. Could be morning. Could be... Oh, my message didn't go through on YouTube saying I'm starting in 10. Whoops. Well, no worries. Hi. Am I over zoomed in? I might be. Yeah. So, there are hamsters in my pocket. Yes. It's Monday. It is indeed Monday. We are here to do some learning. Yeah, let's start. I don't think I have any housekeeping related things. Oh, I do. Yay, I do. I tried to make some emotes and animated emotes. Yesterday I made them. Took me I think it took me 2 hours in the whole process. Oh, I thought there is no sound. Okay, there is sound. The part where I had to upload it, that didn't work. It just I gave up yesterday, and then when I tried again today, 20 minutes ago, it just uploaded without no issue. But 2 of them went through without problem. Around I think 4 animated, 3 non-animated, or 2 are pending approval. So yeah. So I will need feedback from how they look, because I think they might be too small, and I don't know how many times I'm allowed to update something or remove it and stuff. So I don't want to get banned, but I also want to have it look cool, and not be too small. That was that. Now we can what happened here? No. Fine. Well, that's sad. I put this model to train, and I thought it would take 8 hours. 14 hours later, it's less than 10%. Great. Okay. Let's go here. Where were we? I'm thinking I want to start with CMU and then go to Hugging Face, because this requires more concentration and attention, and sometimes I lose that.
Model did really well.
So I think I'm gonna just let it play, even though I can say I was not paying as good attention as I should have yesterday, and see if it's my loss. Yeah, because I hope through the assignment I will be able to understand things better. I don't know when he gives the assignment, based on this here. Okay, if I go to course details, grading frequently, I don't see any timeline. I haven't tried, no, I don't think it's possible. Assignment 1 is individual, which is cool. Okay, I mean, it was due their own timeline. Huh. even assignment 2 is already due. Ah, even assignment 3 is passed. But the class is still uploading, right? So would there be more assignments? Because let me see, when is the most recent video? 11 days ago. See? نتر مش يعني راح. Wait. Okay. So let's play.
At text classification and other simple tasks like that, because it was able to, share features of the words and then extract combinations of the features. So in order to learn these, we need to start turning to neural networks. And the reason why we need to start turning to neural networks is because well, I can calculate the loss function of the I can calculate the loss function of the hinged loss for a bag of words model by hand. I definitely don't. I probably could, but don't want to do it for a model that starts to become as complicated as this with multiple matrix multiplications and TANHs and stuff like that. So the way we do this, just a very brief coverage of this because I think probably a lot of people have dealt with neural networks before. The original motivation was that we had neurons in the brain where each of the neuron synapses took in an electrical signal, and once they got enough electrical signal, they would fire. But now the current...
A lot of ML related things are inspired by nature. Even if you look at reinforcement learning, it is inspired by how humans or even animals learn. I was reading this paragraph in this book like months ago, not very recently, but it was talking about a scientist that had hens, in his dorm room. And it was the cutest thing because he would teach them, like, those tests on animals where you give them food if they press something and stuff like that, or I don't know, mazes. But I think, according to the book and according to what I remember, which is not a lot, the idea of reinforcement learning grew from there, I think.
Current conception of neural networks or deep learning models is basically computation graphs. And the way a computation graph works, and I'm especially going to talk about the way it works in natural language processing, which might be a contrast to the way it works in computer vision, is we have an expression that looks like this, and maybe it's the expression x corresponding to a scalar. And each node corresponds to something like a tensor, a matrix, a vector, a scalar. So scalar is kind of zero-dimensional. It's a single value, one-dimensional, two-dimensional, or arbitrary dimensional. And then we also have nodes that correspond to the result of function applications. So if we have x...
Hello, hello. Good late at night. What's up? So mini update. I tried making emotes yesterday. My main issue was that it wasn't uploading, no matter how many times I tried. Then I tried again today, and it did upload, but it's pending approval. Two of them passed through, and why? Oh no. And yes, oh no, because it wasn't uploading. But today it uploaded, and it's pending approval. But two of them did two non-emotes, non-animated, pass through. So yes, are they too small? I actually need feedback. It feels a bit too small. I don't know. Um, yes, and I wanted to keep the, even though I think thank you, the dark hijab blends with the background. I want to keep that uniform style thing, of like the white and the black, and not have, because I change clothes way too much. Hey, good morning, coffee. So yeah, I updated these around just a bit, and the I can show you, can't I? I can show you the new emotes. Huh? Oh, the the hamsters. I have hamsters in my pocket. I know. They just existed as a thing that I could choose. And I chose them. They are added. There were 3 different types of clothes. All of them had hamsters. I expected them to have different animals, but they were all hamsters. I should be able to show you the emotes that I tried to add yesterday. Settings? Not settings? No, not settings. Dashboard. And then emotes. Ya Allah, there we go. Okay, nope. Wait. Okay, showing the screen. I can't zoom in. Oh, I can. Well, you can barely see them. But we have I have those for now. And these two just, I guess because the names are new, they came through, but these names are probably too repeated. Yes. So that's that. Yes. I think it, even though like I didn't do any of the animation because I'm using the app, it still took me like way too long to just prepare it, have it be, I hope so. Again, not made by me. I'm using the app that I is, yes. I don't think you can see it on Twitch, but yes, that's the name of the app. And they have so many emotions. Like I can do one of the gestures here right now. Did I? Oh, I didn't. Huh. I haven't saved all of them because they're not things that I would want to see on chat, but I did like this hump style one that I haven't yet. Yeah. Oh, she doesn't look angry. She's supposed to look. Is it because she's. Okay, let me see. Yeah, okay. If it doesn't see me, it should look angry. Yeah. The end. Let me go back to a neutral position. Okay. Yep. So that was fun. It's cool. Each time I learn something new that I can do. All right. So our professor is telling us why. Well, it started with why we're learning about neural nets, or why we are using neural nets, and then where the idea came from, which is neurons, and then something about graphs.
One-dimensional, two-dimensional.
Always takes ages to manage art assets like emotes. Probably. I tried making them myself, as you saw from my older ones. That was 3 years ago. And just like having different shapes, because I think back then the auto resize wasn't even there. So yes, a folder of like different sizes and then all of that. I guess not consistently though. I think I started streaming 2021. I think, and that would be 3 years ago. Wouldn't that be the case? I don't know if Twitch shows you how long you've been here, like YouTube does. Is there any? All of my about and everything is super old. I really should update some of them. Oh, there was the anniversary that Twitch told me about last time. It was May. Don't know. Yeah, so I guess May 2021 is when I started. But again, very inconsistent. Um, I don't think I streamed at all in 2022. Yeah. And now I'm trying to be consistent because actually my schedule is super different from last year. And I am able to do things that are considered hobbies. This is one of them. um, yep. And like just finding something that tracks my face. I tried a bunch of different stuff. Like carving my own things. Carving my own what is it called? Character, I guess. Using the app, the Japanese app. Um, and then I used Kaleidoscope, I think, to track my face. It would track hands, but very badly. And then when I found this, then it became easier for me. Yeah, and then there became an issue of setup. I don't know why this is becoming how to Twitch for me, but the issue of setup was because this app is phone only. How do I put it on Mac? Because Windows, you have no issue. You can just have an emulator. So I tried Android Studio, running it, the emulator inside, and then the app stopped working within Android Studio. Now I'm just using AnyDesk to, yeah, to using AnyDesk to track my phone's, um, share my phone screen. And the background is, I don't know how interesting that is, but the app allows you to change the background of your, what I do? Background of your character. So like, I'm using chroma key to have it be green. Yes. um, yeah. So it's like the fact that things are working right now is a miracle, but they are. And I'm happy about it because I get to learn stuff and give time to learning stuff, and not be too distracted because then I'd probably be like watching something on YouTube, listening to something, and also learn from cool people and also talk to cool people. Thank you. You are extremely kind. Question: when was the last time you streamed? I don't think I have gotten your notifications recently because it's been a while since, like I'm talking at you then. Um, right? Same reason? That is actually really interesting. Because I remember, like, God knows how long ago, I was like, oh, Friday. Huh. Huh. Friday. I guess Fridays are like family day here, so I should be on my phone less, but I don't know. Um, hmm. I'm thinking, like, what was I doing Friday? Um, yeah. I remember thinking, like, I need a camera on me because I know when there are people around me that I want to impress, I do a better job. I'm such a bad people pleaser. So I'm glad that I'm not the only one who had the same thought of hoping that having people watch you or just be there with you makes you less distracted. Yeah, let's do some learning.
Or arbitrary dimensional. And then we also have...
If someone might watch me, I'm not going to lose 4 hours to random YouTube videos. Yes. But I mean, they're not that random, actually. I do have I don't know if it was recommended to you, but there's this really interesting YouTube video about why the glitter emoji became, like, why AI stole it. That was really interesting. People say, how can you stay more productive on Twitch? You spend half your time talking to chat. No, 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 no. That's actually different. But even half is more than zero. Absolutely. I agree with you on that. 100%. Um, like, like you said, assuming you have 2 hours to work, I might work just 30 minutes. But if I'm working an hour, then that's an improvement. I mean, this is not work. This is learning. But yeah. Yeah. I'm also like super, not harsh. Like, I'm doing something that's counterintuitive by, I know if I listen to Quran, I concentrate better, but sometimes I just don't do that. And I'm like, you know what? Just one more video and then I'll play Quran, and then I just don't. Um, so yes, easily distracted. Um, not like, it's weird. Like, you don't want that, but you do it. It's a bit not fun. um, Indeed, vibing. uh, yes. The only glitter video the algorithm recommended me is a glitter conspiracy? Huh. I know another glitter video which is by a nail artist about, is that like how glitter, there are less glitter in the world. Is that what um you are talking about? Because I don't know if it's called glitter. Um Spark? How AI stole the sparkles emoji. Um do look into that, because it is like, you'd be surprised where the video takes you. You'd never expect where it would take you. Um, okay, I'll spoil a tiny bit. It takes you to Japan, um, which one would not expect for a video about emojis. But why? You'll see. I'll stop with the spoilers. Um, oh, okay. What is a graph? That's why we have edge node. Edges are... I've created a lot of graphs back in my day. A function argument, and also a data dependency. They're just pointers. That part I know. They are pointers to nodes with an incoming edge is a function of that edge's tail node. A node knows how to compute its value and the value of its derivative, WRT. Each argument as in parameter times a derivative of an arbitrary input. Okay.
Or arbitrary dimensional. And then we also have nodes that correspond to the result of function applications. So if we have x be a vector, we take the vector transpose. And so each edge represents a function argument. and also a data dependency. And a node with an incoming edge is a function of that edge's tail node. And importantly, each node knows how to compute its value and the value of its derivative with respect to each argument times the derivative of an arbitrary input. And
arbitrary
functions can be basically arbitrary functions. They can be unary, nullary, unary, binary, unary, often unary or binary. And computation graphs are directed and cyclic. And one important thing to note is that you can have multiple ways of expressing the same function. So this is actually really important as you start implementing things. And the reason why is the left graph and the right graph both express the same thing.
Okay.
The left graph expresses x transpose times a times x.
Right.
Whereas this one has x, a, and then it puts it into a node that is x transpose ax. And so these express exactly the same thing, but the graph on the left is larger.
Oh, these two are the same thing? How?
The reason why this is important is for practical implementation of neural networks. The larger graphs are going to take more memory and going to be slower usually.
Ah.
And so often in a neural network toolkit like PyTorch, which we're going to look at in a second, you will have something, you will be able to do this, or you'll be able to do like,
I don't know what this is.
this. So these are two different options. This one is using more operations, and this one is using less operations. And this is going to be faster because basically the implementation within PyTorch will have been optimized for you. It will only require one graph node instead of multiple graph nodes. And that's even more important when you start talking about like
And this has to do with neural networks because the nodes are neurons, right?
attention or something like that, which we're going to be covering very soon. Attention is a very multi-head attention or something like that is a very complicated operation. So you want to make sure that you're using the operators that are available to you to make this more efficient.
Okay.
And then finally, we could like add all of these together at the end. We could add a constant. And then we get this expression here, which gives us kind of a polynomial expression.
Is this the start, or do we have multiple start nodes?
Also, another thing to note is within a neural network computation graph, variable names are just labelings of nodes. And so if you're using a computation graph like this, you might only be declaring one variable here, but actually there's a whole bunch of stuff going on behind the scenes, and all of that will take memory and computation time and stuff like that. So it's important to be aware of that if you want to make your implementations more efficient and other things. So we have several algorithms that go into implementing neural nets. The first one is graph construction. The second one is forward propagation. And graph construction is basically constructing the graph, declaring all the variables, stuff like this. The second one is forward propagation. And the way you do this is in topological order. You compute the value of a node given its inputs. And so basically you start out with all of the nodes that you give as input. And then you find any node in the graph where all of its tail nodes or all of its children have been calculated. So in this case, that would be these two nodes. And then in
tail nodes are children? This is forward propagation. Okay.
Arbitrary order, or even in parallel, you calculate the value of all of the satisfied nodes until you get to the end. And then the remaining algorithms are backpropagation and parameter update. I already talked about parameter update using stochastic gradient descent. But for backpropagation, we then process examples in reverse topological order. calculate derivatives of parameters with respect to the final value. And so we start out with the very final value. Usually this is your loss function. And then you just step backwards in topological order to calculate the derivatives in all of these. So this is pretty simple. I think a lot of people may have seen this already, but keeping this in mind as you're implementing NLP models, especially models that are really memory intensive or things like that, is pretty important, because if you accidentally, like for example, calculate the same thing twice, or accidentally create a graph that is manipulating very large tensors and creating very large intermediate states, that can kill your memory and cause big problems. So it's an important thing to be aware of. Cool. Any questions about this? Okay. If not, I will go on to the next one.
Thank you.
So neural network frameworks. There's several neural network frameworks, but in NLP nowadays, I really only see two, and mostly only see one. So that one that almost everybody uses is PyTorch.
True.
And I would recommend using it unless you.
Fine. Okay. PyTorch. The auto CC is seeing it as PyTorch. That sounds yummy.
You know, if you're a fan of like Rust or, you know, esoteric, not esoteric, but like unusual programming languages, and you like beauty and things like this, another option might be JAX. So I'll explain a little bit about the difference between them, and you can pick accordingly. First, both of these frameworks are developed by big companies, and they have a lot of engineering support behind them. That's kind of an important thing to think about when you're deciding which framework to use, because you know it'll be well supported. PyTorch is definitely most widely used in NLP, especially NLP research, and it's used in some NLP projects. JAX is used in some NLP projects. PyTorch favors dynamic execution. So what dynamic execution means is you basically.
Oh, really? So you like beauty. I never actually tried, so I don't know like what would be the difference. Are you learning it because you like it, or are you learning it because you need to? Because like I used to say I like R, but I never got into it. Then I needed it for work, and now I can say I could probably understand R code if you give it to me. So next, I don't know if you've streamed it, but next one should be about that. Some learn Rust due to peer pressure. Bad friends do stuff like that too, don't they? Learning because I want to use it to rewrite. No way. Do you think it will make it like more optimized or easier to maintain, to go forward with it? Because like just saying rewrite something, that scares me sorta. Good luck with that. I think you'll probably learn a lot of cool stuff. Theoretically, you should make it much harder to write bugs. And make concurrency easier. I don't know what you mean by concurrency, as in things happening in parallel? I don't know. But if it makes has the performance of C with safety of not C. No way. Yeah. The existing one is a big pile of spaghetti. Yeah, maintenance not easy. Didn't know like, cause like they say Python should be fast, but obviously C is faster. Didn't know Rust was like competing with C for performance. That's pretty cool. I do wish you luck with trying that, but yeah, I hope, because like when you start a project, you're so excited about it. I hope that continues, because with good people around you, it should. Yes, and I will give you no technical support, but for emotional and any other sort of support that I can give, let me know. Okay, back to PyTorch.
Basically create a computation graph and then execute it every time you process an input.
Wait.
And then is you basically create a computation graph and then execute it every time you
Dynamic.
process an input. In contrast, there's also, you define the computation graph.
Stanford Hazy Research. People have released their ML language. Thundercats? I have not heard of that. Did they steal the name from High School Musical?
First, and then
Wait. Thunder Kittens. Thank you. Hi. Sun Ada. Best of luck. Yeah, the course is tough. Let's go. Thank you for that motivation. let me get some more motivation. um, um, this course is from Carnegie Mellon University. Um, um, I needed to be shown that when I Google Thunder Kittens, this is what came up. Um, and then the hazy research. So, oh yay, thanks. Um, is this AI? Oh, that's very recent. I remember. Oh, so it is something from the past. Thundercats. Huh. They did the flash attention stuff so they know about making transformers fast. That is really interesting. I'm gonna be mean and say, post this on on Discord, because why Thunder Kittens? We wanted something that was adorable and cute. And there's so many macho head games in the current names. True. Let's be fun and welcoming. That is really sweet. Um, Hazy research. Attention forward. Thank you for the link and the information. Wait. Ah. Facebook AI research. PyTorch is developed by them.
Executed over and over again.
Because TensorFlow's Google, PyTorch is Meta.
So in other words, the graph construction step only happens once, kind of at the beginning of computation, and then you compile it afterwards. And it's actually PyTorch supports kind of defining and compiling, and JAX supports more dynamic things, but the way they were designed is kind of favoring dynamic execution or favoring definition and compilation. And the difference between these two is this one gives you more flexibility. This one gives you better optimization and more speed if you want to do that. Another thing about JAX is it's kind of very close to NumPy in a way. Like it uses a very something that's kind of close to NumPy. It's very heavily based on tensors. And so because of this, you can kind of easily do some interesting things like, okay, I want to take this tensor and I want to split it over 2 GPUs. And this is good if you're training like a very large model and you want to put kind of this part of the model, you want to put this part of the model on GPU1, this on GPU2, this on GPU3, this on GPU4. It's slightly simpler conceptually to do in JAX, but it's also possible to do in PyTorch.
Okay.
And PyTorch by far has the most vibrant ecosystem. So like, as I said, PyTorch is a good
used by a
default
lot
choice,
of people.
but
True.
you can consider using JAX if you like new things. Cool. Yeah, actually, I already talked about that. So in the interest of time, I may not go into these very deeply, but it's important to note that we have examples of all of the models that I talked about in the class today. These are created for simplicity, not for speed or efficiency of implementation. So these are kind of PyTorch-based examples where you can create the bag of words model, a continuous bag of words model, and a deep continuous bag of words model. And all of these, I believe, are implemented in model.py. And the most important thing is where you define the forward pass. And maybe I can just give a simple example of this, but here, this is where you do the word embedding.
I think is looking at GitHub because these are here. Bag of words, continuous bag of words, deep continuous bag of words, and I guess this model would be...
This is where you sum up all of the embeddings and add a bias. And then this is where you return the score. And then, oh, sorry. The continuous bag of words model sums up some embeddings, or gets the embeddings, sums up some embeddings, gets the score here and then runs it through a linear, or changes the view, runs it through a linear layer. And then the deep continuous bag of words model also adds a few layers of like linear transformations and damage. So you should be able to see that these correspond pretty closely to the things that I had on the slides. So hopefully that's a good start if you're not very familiar with implementing models in PyTorch. Oh, and yes, the recitation will be about playing around with sentence piece and playing around with these. So if you have any, look at them, have any questions, you're welcome to show up for a walkthrough. Cool. Any questions about these? No? Okay. So a few more final important concepts. Another concept that you should definitely be aware of is the atom optimizer. So there's lots of optimizers that you could be using, but almost all research in NLP uses some variety of the atom optimizer.
Okay.
And the way this works is...
Oh, so I'm not the only one. I do get confused. He was going through the code, I guess, on another screen. But thank you for making me not feel alone about him jumping around. Even though he's a really kind explainer, and I understand it's called advanced NLP, so it's my, in a way, my fault for choosing this course. But I like him too much to not watch the course.
Optimizes the it optimizes the model considering the rolling average of the gradient and momentum. And the way it works is...
I think he goes advanced and then he and then sorry, and then he goes back. So it's some sort of the seesaw. Yep, that.
Here we have a gradient. Here we have momentum, and what you can see is happening here is we add a little bit of the gradient in. How much you add in is with respect to the size of this beta 1 parameter, and you add it into the momentum term. So this momentum term like gradually increases and decreases. So in contrast to standard gradient descent, which could be updating
I know gradient descent.
kind of like very differently on each time step. This will make the momentum kind of transition more smoothly by taking the rolling average of the gradient. And then the second thing is by taking the momentum. This is the rolling average of the, I guess, gradient variance. Sorry, this should be variance. And the reason why you need to keep track of the variance is some parameters will have very large variance in their gradients and might fluctuate very strongly, and others might have smaller variance in their gradients and not fluctuate very much. But we want to make sure that we update the ones, we still update the ones that have a very small change in their variance. And the reason why is kind of, let's say you have a multi-layer network.
Okay.
Or actually, sorry, a better
example.
A better example is like, let's say you have a big word embedding matrix, and over here we have like really frequent words, and then over here we have gradient.
Frequent words, and then
we have like less frequent words.
Less
we want to make sure
words.
that all of these get updated appropriately. All of these get like enough updates. And so over here, this one will have lots of updates. And so kind of the amount that we update, or the amount that we update this will be relatively large. Whereas over here, this will not have very many updates. We'll have lots of zero updates also. And so the amount that we update this will be relatively small.
Does that mean in a way this helps with the what does update mean though? Applying functions? Let's see.
So this kind of squared gradient here will be smaller for the values over here. And what that allows us to do is it allows us to, maybe I can just go to the bottom. We end up dividing by the square root.
He is sharing a different screen. Now I'm sad about it.
This, and because we divide by the square root of this, if this is really large, like 50 and 70, and then this over here is like 1, 0.5, 0.3 or something, we will be upweighting the ones that have like less square gradients. So it allows you to upweight the less common gradients more frequently. And then there's also some terms for correcting bias early in training, because these momentum and invariance or momentum and squared gradient terms are not going to be like well calibrated yet. So it prevents them from going very haywire at the beginning of training. So this is the details of this again are not like super important.
Thank you.
Another thing that I didn't write on the slides is now in transformers, it's also super common to have an overall learning rate schedule. So even Adam has this ADA learning rate parameter here. And what we often do is we adjust this. So we start it low, we raise it up, and then we have a decay.
I just wish they, yeah. Again, I'm trying not to be, not to raise the fact that he when he moves away to the board, his mic gets, like, his voice gets calmer, because my current setup is not the best. when my setup becomes better, then I will complain and say he should have some sort of microphone attached. Um, One of the easiest way to have good audio is just have your phone record and then sync the audio. Like so easy and so good good voice. Not so easy for me with the streaming. Yes, but easy with stuff you can edit later.
At the end, and exactly how much.
I know. I know. Yeah. Um, True. This is Carnegie Mellon University, so and yes, like just the amount of lectures that are shared, like CS50, Stanford, MIT, um, definitely something we can't complain about.
To do this kind of depends on, how big your model is, how much data you're training on eventually. And the reason why we do this is transformers are unfortunately super sensitive to having a high learning rate right at the very beginning. So if you update them with a high learning rate right at the very beginning, they go haywire and you get a really weird model. Um, and but you want to raise it eventually so your model is learning appropriately. And then in all stochastic gradient descent, no matter whether you're using atom or anything else, it's a good idea to gradually decrease the learning rate at the end to prevent the model from continuing to
Overfitting?
fluctuate and getting it to a stable point that gives you
Huh.
good accuracy over a large part of data. So this is often included, like if you look at any standard transformer training recipe, it will have that included in it as well.
Cool.
So that's kind of the
Transformer training recipe.
go-to optimizer.
Training.
Are there any questions or discussion? There's also tricky things like cyclic learning rates where you decrease the learning rate, increase it, and stuff like that, that I won't go into that. We don't actually use it that much. Second thing is visualization of embeddings. So normally when we have word embeddings, usually they're kind of large. And they can be like 512 or 1024 dimensions. And
I think it's like momentum up somehow not getting stuck in local minimum. Having it jump around, so learning rate is high, but then when you're at the end of your training, you don't want it to continue the jumping around, right?
so one thing that we can do is we can down weight them, like reduce the dimensions or perform dimensionality reduction and put them in like 2 or 3 dimensions, which are easy for humans to visualize. This is an example using principal component analysis, which is a linear dimension reduction technique. And this is an example from 10 years ago now. One of the first major word embedding papers where they demonstrated that if you do this sort of linear dimension reduction, you get actually some interesting things where you can draw a vector that's almost the same direction between like countries and their capitals, for example. So this is a good thing to do, but actually PCA doesn't give you, in some cases, PCA doesn't give you super great visualizations. Sorry. Yeah. For things like this, I think you probably would still see vectors in the same direction, but I don't think there's a reason why I'm introducing nonlinear projections next, because the more standard way to do this is nonlinear projections, in particular, a method called Tisney. And the way they do this is they try to group things that are close together in high dimensional space so that they're also close together in low dimensional space. But they remove the restriction that this is linear. So this is an example of just grouping together some digits from the MNIST data set.
Really?
Or sorry, reducing the dimension of digits from the MNIST data set according to PCA. And you can see it gives you these kind of blobs that overlap with each other and stuff like this. But if you do it with Tisney, this is completely unsupervised, actually. It's not training any model for labeling. The labels are just used to draw the colors. And you can see that it gets pretty coherent clusters that correspond to like what the actual digits are. However, one problem with Tisney, I still think it's better than
the clusters get better defined, but the directions have no meaning. Interesting.
PCA for a large number of applications, but settings of Tisney matter. And Tisney has a few settings. Kind of the most important ones are the overall perplexity hyperparameter and the number of steps that you perform. And there's a nice example of a paper or kind of like online post that demonstrates how if you change these parameters, you can get very different things. So if this is the original data, you run Tisney and it gives you very different things based on the hyperparameters that you change. And here's another example.
This looks cool.
You have two linear things like this. And so PCA, no matter how you ran PCA, you would still get a linear output from this. So normally, it might change the order, it might squash it a little bit or something like this. But if you run Tisney, it gives you crazy things. It even gives you like DNA and other stuff like that. So you do need to be a little bit careful that this is not
like this and this. Like what? Like these two make somewhat sense, but they're even that makes a little bit more sense. But these two are like what? How is this coming from this?
not necessarily going to tell you nice linear correlations like this. So like, let's say this correlation existed. If you use Tisney, it might not necessarily come out if you use Tisney. So. Cool. Yep. That's my final thing. Actually, I said sequence models in the next class, but it's in the class after this. I'm going to be talking about language modeling. So, cool. Any questions?
I also would appreciate if the question part was recorded, because I really enjoyed the discussion of Jeremy Howard's classes. Yep. Hey, I remembered where I am in this part. Subword tokenization. Let's do a quick, tiny recap. We were in tokenizers, and then we talked about word-based tokenizers and how you split on something, and the fact that you will always have a big vocabulary, because also you have to be careful with words that are similar but recorded differently in the vocab. And unknowns, also something we talked about. And then we came to character-based tokenizers. And then like half of the video is like character-based, the best. You have a limited amount of characters. Your vocabulary is not too big. It's easy to deal with. And then at the end it's like, oh yeah, but you lose, well, you don't lose all meaning. Character-based tokenization is good for languages where a character has information, but Roman-based languages don't. Yeah. Yep. And then we said best of both worlds is subword tokenization. So let's see what that is. Prepare for a whoosh. There it is.
Let's take a look at subword-based tokenization.
Yep, I always have to adjust the audio between CMU and HuggingFace. Not just Roman, like Japanese katana characters have no meaning to write. Cannot answer you that. I'm repeating what the video said, because like Roman based we're 100% sure, but the example they gave for things where character does have meaning was kanji, right? I think, which is Chinese. I always thought kanji is Japanese. I don't know. is it talked about up here? Chinese, yeah. And then becomes Latin languages. I don't know for hunger, because I don't know if the bits are considered one character. They should be, but I don't know if they are. The parts, and then you can have one segment mean something. For example, like the word for water, mue, is written that way. So like water in Korean, mue. That's one part, you know? So, but I don't know if this is considered one character, or is the M and the U and the R different characters or not. Would be cool, but I don't know. So I guess subwords should help us in that.
Understanding why subword-based tokenization is interesting requires understanding the flaws of word-based and character-based tokenization. If you haven't seen the first videos on word-based and character-based tokenization, we recommend you check them out before looking.
Information isn't how to say the word, not what the word as a whole means. Really? The information is, you mean it's information? Oh. What I said is about how the word is said instead of what it means, or for hunger? Oh yeah, true. I guess, because like these sections are like do I have any examples? Oh yeah. I don't know. The example that I have is like how Koreans take English words and make it their own. For example, the word army becomes ami. The R is just nowhere to be found. And it's two parts. Yeah, for example, I think like character-based models might be better at arithmetic, but worse with dates. Huh. Interesting. I didn't take that into account. Numbers and dates. Because when you're talking about language, you know, having ChatGPT be bad with numbers and dates is also something. Not dates, I don't know. Just with math. But you're saying arithmetics, so are we talking about the back end or the front end? ChatGPT is better with remembering dates, but had to learn to add on like subword combinations. Maybe. I don't have enough information. Because of the tokenization. I think you shared the link last time about what ChatGPT sees from OpenAI. So, yes. Let's see, what exactly do you mean by subwords and how do we decide on them?
Looking at this video. Subword-based tokenization lies in between character-based and word-based tokenization algorithms. The idea is to find a middle ground between very large vocabularies, a large quantity of out-of-vocabulary tokens, and a loss of meaning across very similar words for word-based tokenizers, and very long sequences as well as less meaningful individual tokens for character-based tokenizers.
Okay.
These algorithms rely on the following principles.
So technically those two are the cons of using them. Character-based. Oh yeah, a sequence would be really long. Like a word would be each of its characters, so that's also a con.
Tokenizers. These algorithms rely on the following principle. Frequently used words should not be split into smaller subwords, while rare words should be decomposed into meaningful subwords. An example is the word dog. We would like to have our tokenizer to have a single ID for the word dog, rather than splitting it into characters.
Rare words should be broken apart, but words with a lot of frequency should be left as they are. That's a good rule.
DONG. However, when encountering the word dogs, we would like our tokenizer to understand that at the root, this is.
Also, I keep stopping him, but I do have another note, which is, why would dogs be rarer than dog if it's, I don't know, like a story about dogs?
Still the word dog with an added S that slightly changes the meaning while keeping the original idea. Another example is a complex word like tokenization, which can be split into meaningful subwords. The root of the word is token, and ization completes the root to give it a slightly different meaning. It makes sense to split the word into two.
I just realized that yesterday I forgot the word for root, like the root of a word, and now the guy just said it. I was like, yeah, obviously. Because I kept thinking it in my language and was not able to express what I meant.
Token as the root of the word, labeled as the start of the word, and ization as additional information, labeled as a completion.
Maybe it's a contrary example that is meant to seem to make sense to those who have studied NLP, because like the root word seems like it should be more frequent. That makes sense on a human level, but maybe text to text it would be different. But also like the idea of rare words being broken down while more frequent words shouldn't be broken down, like that makes a lot of sense to me. Maybe the example was, like you said, not the best.
Of the word. In turn, the model will now be able to make sense of token in different situations. It will understand that the words token, tokens, tokenizing, and tokenizations have a similar meaning and are linked. It will also understand that tokenization, modernization, and immunization, which all have the same suffixes, are probably used in the same syntactic situations. Subword-based tokenizers generally have a way to identify which tokens are a start of word.
I was about to ask that. Not just like the start of an end of word, but do we keep the parts somehow together, or do we just say token, another word in our vocabulary, and ization is another word? Then we lose things again, don't we? So let's see how that's solved.
Which tokens complete start of words. So here token as the start of a word, and #ization as completion of a word. Here the ## prefix indicates that ization is part of a word rather than the beginning of it.
But do we keep it? I think if both dog and dogs are rare, you get more training on what dog means if dogs is split into dog plus s. And hopefully if other words are learned, that ends other words end in s, the model learns about plurals. I think that's the idea. That's pretty cool.
The ## comes from the BERT tokenizer based on the word piece algorithm. Other tokenizers use other prefixes which can be placed to indicate part of words, like seen here, or start of words instead. There are a lot of different algorithms that can be used for subword tokenization, and most models obtaining state-of-the-art results in English today use some kind of subword tokenization algorithm.
Was the professor talking about byte pair encoding the other time? Because I saw that somewhere, and I don't think it was on Hugging Face, but we're talking about word pieces here. Hi. Thanks for the follow.
SVGKN just followed. CL welcomes you.
Welcome to this corner of the internet. Wa alaikum assalam wa rahmatullahi wa barakatuh. Thank you, SVGKN. Welcome to this tiny corner of the internet where we worry about how words are split. Isn't that a fun thing to worry about? I keep reminding myself that when I get too worried and anxious, I mean, just to keep my faith, but also to know that the things I'm worrying about are very trivial and fortunate.
These approaches help in reducing the vocabulary sizes by sharing information across different words, having the ability to have prefixes and suffixes understood as such. They keep meaning across very similar words by recognizing similar tokens, making them up.
Yes, whoosh, ended. Cool. That was actually informative because I didn't understand the idea of subword tokenization, and now if it's brought up in elsewhere, I will know the main idea. So, subword tokenization algorithms rely on the principle that frequently used words should not be split into smaller subwords, but rare words should be decomposed into meaningful subwords. Main idea. For instance, annoyingly, that's a good word, might be considered as a rare word and could be decomposed into annoying. Why not annoy plus ing plus ly? Now I'm annoyed. And ly. These are both likely to appear more frequently as standalone subwords. While at the same time, the meaning of annoyingly is kept by the composite meaning of annoying plus ly. Here is an example showing somehow a subword tokenization algorithm would tokenize the sequence let's do tokenization. Let's is not. Okay. Also, when the model sees dogs as a word, it sees nothing about what characters are in the word. Okay. So it has to separately learn that it is a plural and cannot learn like a rule for English plurals. You mean like it should learn how we make plurals, right? But also what I am curious about is do we just let the model learn how to separate? It can't see it ends in an S. True. I mean, can it see the difference between dog and dogs, or does it just see an ID? Just when we say annoying becomes annoying plus ly, and dog becomes dog plus dogs becomes dog plus s, how does it see that? Has to learn the difference from text. Like if you asked me to do that, I'd say compare the less rare words with the more rare words and take away suffixes and prefixes. I don't know if we take away prefixes, but I don't know if that's. I doubt that's how it's done. But it has to learn difference from the text, like you said. So yes, let's is not broken down. Do is fine. Token plus ization is broken down, and I feel like we add one inductive bias for language, but remove another. Language is like a beast. It's an alive beast. You cannot tame it, honestly. But I like the fact that each of them have this, like, the word is ending here, the word is ending here. This has not ended, so the word is ending here. So at least we can see that, right? These subwords end up providing a lot of semantic meaning. For instance, in the above example, tokenization was split into token and ization, two tokens that have a semantic meaning while being space efficient. And only two tokens are needed to represent a long word, not like characters. This allows us to have relatively good coverage with small vocabularies and close to no unknown words. The part about unknown words is also useful. Okay. This approach is especially... Why did I see this as awful? It's useful. This approach is especially useful in a... I've seen this word before. I don't know how to read it. Less funny, not funny at all. Maybe an example of the effect is like when ChatGPT is convinced words rhyme. Oh, that is a really good point. Huh. That's a really good point. Thank you. AGLU, agglutinative? I don't know what that means. Just morphologically rich, that's it. Tending to express concepts in complex words containing many... I think I did see that word elsewhere. Okay, made up of a lot of stuff. Do you have any examples? Turkish, Hangulgo, anything from Korean, so that I can understand better. Special NLP word. I think most English speakers wouldn't know it. Is that... We have something from Turkish. That one. No, Spanish? Okay. Anyway. Are you one of these? Are you? Whoa, is that one word? Whoa. That's so cool. Do you get any examples? Such as Turkish, where you can form almost arbitrary long complex words by stringing together subwords. Yeah. Is Arabic one of those? I don't know. Can confirm. I was born in England and did not know that word. I have seen the use of the word morphologically complex languages, like, I guess, Arabic, Turkish, Korean. Good to know. You were born in England, that's cool. I think German might be... Oh, yes. That absolutely is true. Germans have a lot of long words. Are they made up of... Yeah, I think they are made of other words that already exist, but make up new meanings, like Schadenfreude is one of them, right? I don't know if I said it the way it should be, but yeah, that one I've heard quite a lot. Unsurprisingly, there are more techniques out there. Yes, byte level, BPE, is used in ChatGPT. Well, GPT-2, not ChatGPT. Word piece is used in BERT, sentence piece, or Unigram, as used in several multilingual models. Multilingual. Yeah, multilingual would be not easy to have your tokenizer learn to differentiate between things. I guess that would be a different struggle. You should know how sufficient knowledge of how tokenizers work to get started with the API. Okay. I do want to circle back to that point of not knowing. When I said circle back, I did make air quotes because it was supposed to be a joke. Not knowing complex words, because as a person, like I wouldn't even call this well, it is second language, not really. It's like a parallel second language. Speaking English as a second language, I think the learners are hard on themselves for not knowing all the complex words, like, and then a normal human wouldn't really care. Like, I guess that's different. The fact that I feel like I'm losing words in my native language because everything around me is in English. And yeah. Okay, struggles of a person with a working language and a home language. Yeah, the part about losing your own language. I mean, I'm not saying I'm losing my language. I'm just saying when I'm expressing myself, um, it becomes easier for me to speak in English than sometimes. Because even the other day, I was doing something and I was instructing some kids, and the kid didn't know me, and he was like, "Are you speaking in English or are we speaking in our language?" And I was like, "I'm speaking in my language." He was like, "You keep using English words." I was like, "Okay." I think he was uncomfortable about it. So yeah, sometimes it gets pointed out, sometimes it doesn't. Um, as someone lucky to have English as a first language, I did wonder if it made programming easier. Probably, I don't know. Moving and working in another country, but it's another English-speaking country, so it's easier. Ah, yeah. um, okay, I have another small story, which is when I was a kid, I remember asking, "Why is the Quran in Arabic? Why isn't it in my language?" So, I mean, these are like two different things with programming languages, but it's surprising when something so concrete is in a language and you're like, but why isn't it in my language? um, but yeah, there are different divine books in different languages, so I guess the Arab nation needed it the most. Um, okay. Yeah, I will point out that programming is technically in two different languages because color can be written with the U and without the U. So that's like two different languages. So that's fair enough for me. In HTML, I think. We joke about American thinking their Christian Bible was written in English. um, I will blame the British for different things. Okay. I'll blame them for uh the map of Iraq and not the U in color. Because they drew our country basically. Sorry, getting too dark. Mr. Collins spelling reform remove the U. What is that? Is it is it is that supposed to be American? The Mr. Collins spelling reform? Or is it British? Because if you take away the U from British people, oof, you took away their you don't need to apologize. Oh, okay. Ah, okay. Um they drew a lot of maps. They had a hobby of just, piecing. I think they saw the world map as a puzzle and they wanted to make it their own. Um, um, yeah, I know they were really good artists. And each time they saw anything that had to do with oil, and they were like, you know what? I'm gonna color that in and make it mine. um, I think I've recommended the book the Silk Road before, but I'll do it one more time because I learned about a lot of oil-related information that I was not expecting. This book. You can't see it because of my head. Removing you from color is like the smallest taste of being multilingual. I mean, language is complex. We cannot just put it in a box and say because the U isn't there, it doesn't count. No, no. Yes, it's an alive beast, and we should treat it as such. Right. Let's leave the crayons and get back to tokenization. Hi. I know you got gerrymandering. I guess they also like drawing. That's really messed up. I agree. It's like cheating in broad daylight, isn't it? Yeah. I mean, we have parties that have a city in their, grasp. So, I guess you guys they're more states, and then neighborhoods. Yeah. And I think I didn't realize that it was written with a G and not a J, because I thought it just meant some sort of Jerry, some guy named Jerry. Yep. I will say that I don't have enough political information, but I have just enough. I probably know the same amount of information about the American political landscape than in my country. Is that useful? I don't think so. Okay. So, they say data is the new oil, so yeah. I hope that helps with the map drawing. Loading and saving tokenizers is as simple as it is with models. Yep. You can has the same two methods, from pre-trained and save pre-trained. These methods will load or save the algorithm used by the tokenizer, a bit like architecture of the model, as well as its vocabulary, a bit like the weights, huh? But do we see both or not? Sound is a bit low. Yes, thanks for letting me know. Sometimes I have to remember to raise my voice because the thing that I'm using has a low sound. Rafiqul Islam. Whoa, that's a cool name. Hi there, friend. Are you? Because to be a Rafiqul Islam, you'd have to be also Muslim, right? That's cute. Rafiq means friend, by the way. To those. Hello. I will try, inshallah, to fix the sound issue. I forgot to get the other mic that I have access to yesterday, and then I fell asleep, and then this morning I couldn't get it. So again, I will try to test that. But then I have the plan of getting a new mic. So inshallah, when I do that, I'll make sure I get something good. We'll see. So then things will be good. Also, I don't know how many people are on the YouTube side, but please do talk if you feel like talking. As much as I talk to the cool people on Twitch, I also like to talk to the cool people on YouTube because I get both chats. I see both chats. Yep. Loading the BERT tokenizer trained with the same checkpoint as BERT. So yes, we can load tokenizers, auto tokenizer, BERT tokenizer. We have a list, and if you choose auto tokenizer and give it BERT, then it will technically load BERT, because then, similar to AutoModel, the auto tokenizer will grab the proper tokenizer class in the library based on the checkpoint name, meaning it has a base of pre-listed models and tokenizers, I guess checkpoints, that it will give it to you. So can we try, I'm gonna go to the hub and see if there are multilingual tokenizers and if I can use them, because that would be fun. And then we can save it to a directory. Before we go to encoding, I think I should be able to do that. Oh, sorry, I have to make a copy first. Sorry. And then I should go to the hub. Okay, so this is a manual split using Python. And then here we are using BERT, then we're using auto tokenizer. For auto tokenizer, I am curious if I can just get any. Do we not have tokenizers? Token. I guess token classification is that tokenizer? Or do we just choose any model and say, do it like this? So let's go to text classification. Turkish. I want to try something Arabic. Turkish again. Because I can't judge Turkish. I don't know Turkish. I just know like hellos and goodbyes. Indonesian. Sure. But would it work? Whoa, something poetry. That's cool. Sentiment. What is? Most of the time these things don't work, but let's try. Would it give me an error of saying I don't recognize the model? But this is from BERT, so it should be fine. And then okay, something's happening. Transformers. Googling the word transformers. And then okay. So from Wikipedia, choosing Arabi, getting. Wow, that is really informative, isn't it? If I take the whole thing, how would it look? I have no idea. where's the beginning? And where is the end? That's too long, isn't it? I should choose less long text. Like this part only. Then going to the beginning, tokenizer. Something happened. I guess it does work. Can I decode it? Oh, I just use this? Uh-oh. Whoa, I got too into the thing and forgot that my screen has a timer. Shoot, sorry. Why did I give you that? I don't even know what these are. I'm supposed to give you... Yep. I'm supposed to give you some of your own text. No? Yes? Okay. Do that. Huh. Whoa. But then how do I know how it... I can't see how it did it. Oh, I do see an extra space here, right? There is no space here. And, okay, it's not made it, chopped up, so that's pretty cool, right? Yay. That made me feel nice. So... we'll talk more about token type IDs in... Where is token type IDs? In chapter 3, we'll explain the... Oh, those. Okay. Attention mask. Good question. Most likely Discord thing. Even for now, I was planning on sending a reminder about who wants to join the Discord thing, because, yeah, because I want to see how it goes. So then there would be no Twitch/YouTube stream tomorrow, and hopefully the Discord thing would happen. Yeah, based on people's availability and if like 2-3 people can join, that would be pretty cool. I don't have any expectations. So yeah, I hope it will be fun. Yeah, so have I. I should have sent my idea was I would send a reminder 24 hours before, which would have been 2 hours ago, I guess. But I can send it after the stream, and then also send it half an hour before, so that if anyone is interested to join us for just talking about cool things we find on the internet regarding ML and NLP research, you can join Discord. I can put it in the chat. I think we already have it in the description box on YouTube. But also, if anyone's interested, we would be delighted, but not... you don't have to. Yeah. Now I'm thinking, do I go to encoding or do I end the stream? Because something tells me... Yeah. Actually, the decoding is super small. Let's see how long this video is. Oh, 3 minutes. That's too much. gonna go. Okay, encoding. I'm happy that I learned about subwords, because like when I understand something, I'm like, yay, I understand something. And then when it goes over my head, I'm like, if I need it, I will force myself to learn it, bit by bit. Yeah. Okay. So let's do a mini recap of what we did. We looked at lecture 2 of the oh, you can't see it because of my head. Scroll more. There we go. Of the CMU Advanced NLP course. It was about word representation and text classification. Next would be language modeling. Cool. I have been going through them a bit faster than I should have because, yay. Sorry. Because I have this theory of like, if I can understand keywords without knowing how exactly they work, it would be easier for me to then later go into understanding how things work. I could be wrong. I might be wrong. So I don't mind going through something with understanding like 60-70% of what's going on, maybe even 50%. And I think the Hugging Face part is spoon feeding me, which I'm a bit happy about. Like it's repeating things a lot, but the lecture is supposed to be here's the start of something, you go follow it. And I hope I can do it, but I don't think I've done it yet. Yeah. So that's the things that we sort of did today. We learned about tokenizers, word, character, and subword. So that was fun. I think that's it for today. Sometimes people ask me about my schedule. Normally my schedule is every day 2 hours ago, but tomorrow I won't be here. Like discussed, I'll be on Discord. Hopefully we'll have an hour of talking there about cool things. And if interested, there's like previous streams on YouTube. But sorry again for the volume issue. I will try to fix it, inshallah. Thank you for anyone being remotely interested in giving me a follow or subscribe or whatever. I'm scared of saying every day. I remember you said it in December. Yes, I did. And then just stop streaming. I am going with it for now. I don't know when it was. I think it was the last week of December. But yeah, I did have a different schedule. Now I have a lot more control over my schedule, but I also understand that it's not uh, it's not easy to maintain, but just having it be like I want it to become a habit for me, the learning part. I'm the least reliable dragon when it comes to streaming. Yeah. Yay! I really should remove these things. December things did get busy, and even like Tuesday, I have some stuff that means that's why it would be easier for me to have a conversation with people and not have it be me focused on something. So yeah, even tomorrow I have this thing that is like taking up a big percentage of my brain right now. But yeah, being reliable when it comes to streaming is like, where's the fun in that? You have to keep people guessing, right? Yep. Being unpredictable is like the new cool thing. Alright. So, I know. Thank you for being here. I know, like, Jews will be going to sleep right after this stream. And I was hoping that you'd fall asleep midstream, but I guess not. I will look forward to the post. It feels like I have homework before it. Aw, I have the same feeling. I feel like I have to be super ready for things. Sleep well. So I should also. Yesterday I tried to do some of the homework about the thing that you shared with us, and then I bailed halfway. I think I will have time today to do that. Some not so fun things happened the past 2 days, so yeah, things are good though. Okay, thanks again for being in this corner of the internet with us. I will have to watch that. That is surprisingly informative and interesting. Yes. Also, you don't have to do anything. Do whatever you like. Yeah. So I'm gonna end the stream. Wow, I'm on time. Um, good night to you. And morning in my case, yes. If you can believe it, I'm going to go and have breakfast now. Hello, hello. The glare video I mentioned is like that, but it's not AI. Huh. Okay. I will look into that. Larissa? Sorry for joining us a bit late. I am about to end the stream. I worry when I said conspiracy sound bad. No. I know there's a conspiracy about glitters just ceasing to exist, something like that. So maybe it's about that. I don't know. Sorry for joining us a bit late. If you are interested, you can. I'm getting into my newscaster sound. If you're interested, you can look at previous lives, or you can join us on Discord, where hopefully we'll do some sort of voice chat tomorrow, same time, 2 hours ago. And then, inshallah, if all goes well, I'll be back streaming on Wednesday. I do enjoy saying inshallah each time I make a promise for the future. Well, alright. I am going to end the stream. If anyone has anything to say, let me know. Otherwise, I will see you Wednesday. Yes. That I've heard somewhere. Let's not name names so that we don't get flagged anywhere. Thank you so much for being here. Also, please take care of yourself and sleep well. I hope you have a lovely rest of your night, day, or yeah, the rest of your time. That sounded ominous. It was half a joke, half not a joke. Honestly. But mostly a joke. Okay. Yeah. Thank you again for being here. I will see you next time. I'm going to end the stream in 5, 4, 3, 2,